Welcome to this lecture, and in this lecture we are going to be discussed about the enumerations in Java data structure. Before the version of JDK5, there lacked one feature that many programmers felt was needed. This is the enumeration. It is a list of name constants. It is supported by the most other programming language through the Java offers the similar types of the features that provide somewhat similar functionality as such as the final variable. Still, programmers are in a eager need of the concept of enumerations. In this lecture, we are going to be learn about what is enumerations and how it is used within Java programming language to do the different tasks. Before proceeding this lecture, we just need to know what is enumerations. Enumeration is a list of name constants, and these Java enumerations define a class type by making enumerations into the class. The concept of enumeration is greatly expanded in Java. The simplest form, Java enumerations, appear similar to the enumerations in the other language like C++ and the Ruby. Expected that the class play a major role in this concept, like here, the enum and the month. So, the enum month is a user-defined data type here, and when just write January, February, March, and April. So these are the user values of the user defined data types. And you can see the enum here. So this is a keyword for this language. So enumeration is used using the keyword which is enum, as you can see here. So the enumerations interface defines the method by which you can enumerate the elements in collection of the objects. The legacy interface has been superseded by iterator, although not deprecated. Enumeration is considered obsolete of the new code. However, it is used by several methods defined by the legacy classes, such as vector and the property, is used by several other API classes, and it's currently in wide separate use in application code. Here, the two different methods to declare the enumeration by summarized. So here you can see boolean and has more, and this is has more elements. So when implemented, it must return the value while there are still more elements to extract, and false when all the elements have been enumerated. And the another method is object next element. So this return the next object in the enumeration as a generic object reference. So here we just go to the simple example of the enumerations. So here I just write enum and pl types, and means pl types mean the programming language types, and high level, so these are the values of the user defined data types, and then machine level, assembly, and middle level. So enumerations of a varieties of the programming language you can see here. So here the identifiers means level language, machine level language abstractor are called enumeration constants. So there are no semicolon with it. So each of them is implicitly declared as a public static final member of the programming language types, means PL types. Here you can see this one, enumerations. Hence, the language of the Java, these constants are referred to as self types, where self refers to enclosing the enumerations. Once the enumeration is defined, programmers can create a variables of its types. However, even through enumerations define a class types, programmers do not initiate an enumeration using the new. Instead, they declare and use the enumerations variables like that of the primitive data types as used before. Like here I just write programming language types and then lang, and then lang which is equal to pl types dot assembly. Means we have the pl types which are languages, and then languages which is equal to pl types, and the language name is assembly here. So this declare the language as a variables of enum types pl types like this here, and you can see. Now I just write if, and then lang which is equal to pl types dot machine level, and close this code here. So these are the two enumeration constant can be compared for checking the equality by the use of is equal to relational operator. For example, this compares the value of the lang as a value machine level. So after that, here I just write switch and switch here, and then lang, and case assembly, and then case middle level. So here I just use switch to use the enum to control the switch cases. It is to be noted that an enumeration's value can also be used to control a switch statement. It is of course necessary that all of the case statement must be constant from the same enum as that used by the switch statement. So you can see here I mentioned switch case statement is a valid statement in Java. Now we just see the enum with values and values of method. Here you can see I just write public static enum type, and then here I just write values, then public static enum and types, and then values of, and the values of string which are str. All enumerations automatically contain two predefined methods here, values and the values of. So these are the general forms and the statements of the value and the values of. Now here we just see the example of the enumerations in Java. Here I just take a package which is enumeration, and then in enumerations I just take an enumeration class, which is here I just write enumeration tester. So this is our enumeration class in Java, which is enumeration tester, and this is our package name. And here I just import the library which is java.util and vector, and util.vector, and another library which is import java.util and then enumeration. Okay, so here our in public enum which is a keyword, and then the class name which is public static void main, and then string arguments. And here I just write enumeration, and which is days. Okay, so this is the value of the user defined data types, and now here I just write vector and day names, which is equal to new vector. I just create the object and then days, which is name dot add, and the day's name is Sunday, and this is the day's names: second, third, fourth, five, six, and here I just write Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So this is the day name here and the day name. So yes, now I just write here. I just call this enumeration, which are days. So days, which is equal to day name dot elements, and this is the names and element. Now here I just write the while loop. So while days dot has more elements, you can see here that has more element method in the enumeration. So now I just system dot out dot print line, and I just call this method in days method calling, which is days dot next element. Okay, so here as you can see I just create a enum, which is the name of the user defined data types and the keyword, and this is the user defined data type. And then the value of the user defined data types are the Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. And now so here you can find an error, which is the enum. So I just change the enum with the class right now, and then I just run this code, which is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and the Saturday. As you can see here, we have the variety of the days in our this program. Now we just see one another program with enumerations, and here I just write the class name, which is enum, and I just remove this code, and here I just write public enum, and enum is the enumeration tester. Now here I just write high level, machine level, assembly, and middle level. Okay, so these are the values of the user defined data types of the enumerations. I just remove these libraries, and here I just create a class, which is the name of enum, and enum.java. Okay, now here I just define the public static void main and then strings arguments, and then here I just create the enum tester, and then language, and then system dot out dot println, and the print line is here are list of constants, and then I just write enumerations tester, and here I just write all types, which are the array which is equal to enumerations dot values. And here I just use the for loop for the enumeration tester, which is a, and the colon of the all types. Okay, and then I just write here system dot out dot println, and the println here is a. So I just want to print the for loop of a, and a which is equal to all types. And then here I just write system dot out dot println, so it's println, and the println is nothing, means empty. And then I just define lang, which is equal to enumerations tester dot values of. So here I just use the two methods, which is the value and the values of, and then I just pass the string as an assembly here, and then system dot out dot println, and the println here is values is, and then I just concatenate this variable which is lang, and I just run this code. So here, and you can see the value is the assembly, and this is the value is method, and then it is a middle level. You can see here it's a middle level, and then value is a assembly here. So now we just go to the another example of the enum in Java. Enumerations serve the purpose of representing a group of named constants in a programming language. For example, the four suits in a deck of playing card may be the four enumerators named club, which are diamond, heart, spade, and a club, belonging to an enumerated type's name, which is suit. Here we have another example, which is include natural enumerated types like the plant, days of the week, color, and directions, etc. Enums are used when we know all possible values at the compile time, such as choices on a menu, rounding modes, command line flags, etc. It is not necessary that the set of constant in a enum types stay fixed for all the time. In early since we just see in Java from 1.5, enums are represented using the enum data types. Java enums are more powerful than C or C++ enums. In Java, we can also add variables, methods, and constructor to it. You can see here we just add the variables and many of the methods which are the value of and values method. The main objective of the enum is to define our own data types and enumerate data types. We can see here this is our own data types here, and then we just call these data types here. Now we just see one another example on the enum, which is so simple, and then enumerations one, and here I just define the enum, and here I just write enum which is color, and now we have the public enum key and then the data types which is color. So we have the color red, green, blue, and it's red, green, and blue. Okay, so these are our three data types. So here I just declare the enum outside the any class, mean I just create a class name which is a color here. enum keyword instead of the class keyword I just define here, which is class, and then I just create a class which is test. Now driven method which is public static void main and string arguments, and here color which is c1 means color one, and I just create an object to it, so color dot, and I just call my data type which is red, and then system dot out dot print line, and the print line here is c1. So here I just write the keyword which is enum instead of class, but here I just write the keyword which is class. Now I just see the output, and here I just call the object only which is red here, and this is the output which is red. Now we just go to the enum and the inheritance. I just told you that we are used enum with inheritance and the constructor also. So all enums implicitly extend java.lang.enum class, as a class can only extend only parent in Java, as an enum cannot extend anything else. ToString method is overriding in java.lang.enum class, which return the enum constant name, and enum can implement many interfaces. Here enums used some of the methods I just use in my last examples, which are the values and the values of, and one another method which is ordinal method. These methods are present inside the java.lang.enum. So the values method can be used to return all values present inside the enums. Order in order is important in enum by using ordinal method. Each enum constant indexed can be found just like array indexed, and the value of the method return the enum constants of the specified string value if this value is exist. Now here we can see the enum example with inheritance. Here I just write package, and the package here is enum, and then inheritance, and where I just create a class, sorry, enum, which is same example color, and we have the red, green, blue color, and it's blue color. Okay, so this program is for demonstrate the working with our values ordinal and the values of method. So here I just create data types which are red, green, and blue. Now here the test class, and the test class here I just write the driven method or a main method which is public void main, and then strings arguments. Here I just call the value, means here the values, I just use a method which is values. Color, so it's a capital color which is array index is equal to color dot values. So I just call my first method which is the values here. So this is get the values from our this color method class. Now I just use enum with loop color and col, which is equal to array. And now I just call the ordinal method to find the index of the color. System.out.println, and the print line here is color plus, and here I just write at indexed plus color dot ordinal method, and just close this code here. Now I just write system.out.println, and the print line here is color dot values, value of method, and here I just pass the value which is red. So here I just use the values of to returns an object of the color with this given constant, and uncommitting second line causes exception, illegal argument exception. And here you can also use like system.out.println, which is a color dot values of blue and green. So I just run this code here, and color, and you can see red at the index 0, then green at the index 1. You can see here red at the index 0, so I just getting the indexing values of that, and then blue at the index 2, so 0 1 2, and then I just print my values of color is red. You can see here. So now we just see the another example with enum and the constructor, and the new package and enum constructor. Here I just create a enum, which is same example color. So enum can contain constructor, and it is executed separately for each enum constant at the time of enum class loading. We cannot create enum object explicitly, and hence we cannot invoke enum constructor directly. Remember that enum can constant constructor, and it has executed separately for each enum constant at the time of enum class loading in constructor, and we cannot create enum object explicitly, and hence we cannot invoke enum constructor directly in constructor. And here I just create this example with enum concrete method only. We have we have not used the abstract method in this example. So enum is a keyword, and then the data type is color, red, green, blue. Okay, then here I just create the constructor, which is private color, and then system.out.println, and then the print line is constructor card for, and then concatenate this dot to string. So this is enum constructor called separately for each constant, and you can see here I just define the enum, which is a keyword instead of class keyword, and this is the enum constructor, which is called the separately for each constructor. And then here I just write this dot to string. Now I just create the concrete means not abstract method, and here public void color, and color is a info here. and then system dot out print line, and the print line here is universal color. Okay, so this is only the concrete method. And then we just go to the class. So class is a test here, and then I just write the driven method or a main method, which is public static void main string arguments. Sorry, arguments. Color, which is c1, is equal to color dot red, and then system dot out dot system dot out dot print line, and the print line is c1, so it is print our this color only. Then c1 dot color info. So now I just run this code, and you can see, first of all, I just call the constructor for red, then green, then blue, and then this color, which is red. And then I just told you that this is the universal color. You can see here it is the main method, which is the color info of, and then I just call c1 dot color info. So this is the universal color here. So these are the some example of the enums with constructor, inheritance, and the enum classes. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about the bit set class in Java data structure. The bit set class creates a special type of array that holds the bit values. The bit set array can increase in the size as needed. This makes it similar to the vector of the bits. This is a legacy class, but it has been completely re-engineered in Java 2 and the version of 1.4. The bitset class defined with two constructor. One is the bitset and another one is bit set and int size. So first one is this, the constructor create a default object. So this constructor create the default object, and then bit, so it's a bit set in int size means this constructor allows you to specify its initial size. For example, the number of the bit that it is can hold. All the bits are initialized by 0. So here I just create an example of the bit set in Java. So here I just import a library which is java.util, and then bit set. Here we have the class name, which is a bit set, and then public static void main. And now I just write bit set, which is the bits 1 is equal to new bit set. So the object to my bit set is bit 1. Now I just create one another object, bit set, and then bits 2 is equal to new bit set, and the value of this object is also 16. Now we have the two objects, which is bits 1 and bits 2. Now I just set some bits here. So for statement, for loop, and then for I int I is equal to 0, I is less than 16, and I plus plus. So yes, now here I just write if I percentage sign of and then 2 v is equal to 0, and here the bracket. Now I just set the bits 1 and set which is the value of I. Now if I percentage sign 5 which is not equal to 0, so here bits dot set and then I, so it's not equal to yes, so bits 2 dot set here. Now I just write print statement and print line which is initial pattern in bits 1 and then system dot out dot print line, and the print line here is bytes 1, system dot out dot print line slash n for the single line break and initial pattern in byte 2. So I just printing the sum of the bits here, so that's why I'm just using these print statement and print dot and then I just write bytes 2. Okay, first I just print my this statement initial pattern in bit 1 and then I just print my this bit means the object to this bit and then bit 2. Now I just print the end bits and here I just write bytes 2 dot end, and here I just write bit 1 and then system dot out, sorry it's system dot out dot print line, and the print line here is slash n and bits 2 and bits 1. Now system dot out dot print line, and the print line here is bytes 2. Now I just print the bits with or, so bits 2 dot I just choose or and then bit 1. Now system dot out dot print line, and the print line here is slash n and then bytes 2 or bytes 1, and then system dot out dot print line, and the print line here is bits, so it's a bits 2, I just call the bit 2 here. Now bit with XOR operator, so I just use the bit with XOR, so bit 2 dot XOR and set the bit 1. System dot out dot print line, and the print line here is slash n and bits 2 XOR and bits 1. So now here system dot out dot print line, and the print line here is bit 2. Now we just check the output for all these printed bits. So I just run this code, and then you can see our initial pattern bit 1 is 0 1 2, sorry, 0 2 4 6 8 10 12 and 14. So it just modulus of 2 here. You can see here it's print only the modulus of 2. Then initial bit of the pattern in bit number 2. So it is a modulus of 5, and then 1, 2, 3, 4, 6, 7, 8, 9, 11, 2, 12, 13 and 14. Then we just print our bits with AND operators. So it's 2, 4, 6, 8, 12, 14, and bit 2 with OR operator of bit 1s, which is 0, 2, 4, 6, 8, 10, 12 and the 14. And we have no XOR bits here with the bits number 2 with XOR operators are empty here. Now we just see one another example with our bits using the constructor. So here new, and then the class, which is the name of bit with constructor. Okay, so now here I just import a library which is java.util, and then the class name which is beacon. So here I just create a constructors of the bit class. So first I just create public static void main, and then string arguments, and then I just write the constructor of the class, which are bit set bs1 object, which is equal to new bit set, and then the no value here, and then bit set, which is bs2, which is equal to new, and then bit set, which is I just write 16 not instead of 6. Yes, now bs1 dot set 0. So here I just set the bit class method. So now bit1 dot set, which is 1, bs1 dot set, which is 2, bs1 dot set, which is 4. Then now I just assign the values to the bit number 2. So bs2 dot set, which is 4, and then bs2 dot set, which is 6, bs2 dot set, which is 5, bs2 dot set, which is 1, and bs2 dot set, which is 2 here, and at the last bs2 dot set, which is 3. Now I just print these two bits. So system dot out dot print line, and the print line here is bs1, and then I just concatenate bs1, then system dot out dot print line, and the print line here is bs2, and then concatenate bs2 here. Now I just run this code. So you can see it's not give us the desired output. So I just run it again. We are not getting a right output for that because I'm just use main. So I just missed n with the main, and now I just run this code. So bs1, which is 0 1 2 3 4, so these are the bits value of our bit number 1, and these are the bit values for our bit number 2, which are 1 2 3 4 5 and 6. 1 2 3 4 5 6 in the sequence. So here there are some important points for the bit set. So the size of the array is flexible in the bit set, and it can grow to accommodate additional bit as needed. Then, as it is an array means a bit set is an array, the index is 0 based, means this bit set index is 0 base, and the bit value can be accessed only by non-negative integer as an indexed. Then we just see the default value of the bit set is boolean, means the false, with the representations of 0 means off. The calling the clear method make the bit value set to the false, and then bit uses about 1 bit per boolean value, and to access a specific value in the bit set, the get method is used with an integer argument as an indexed here. So this is examples of the bit set in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture, we are going to be learn about the vector in the data structure. The vector class implements a growable array of an object. Like an array, it's contain components that can be accessed using an integer indexed. However, the size of a vector can grow or shrink as needed to accommodate the additions or removal of the element. Each vector tries to optimize the storage management by maintaining a capacity and a capacity increment. The capacity is always at least as large as the vector size. It is usually larger because components are added to the vector. The vector storage increases in the chunk size of the capacity increment. An application can increase the capacity of the vector before inserting a large number of components. This reduces the amount of incremental relocation. Vector also has a branch of method around the enumerations and the element retrieval, which are different than the list interface and developer. So, especially those who learn Java before 1.2 can train to use them if they are in the code. All through enumerations are faster, then they do not check if the collection was modified during iterations, which can cause issues, and given that the vector might be chosen for its synchronization with the attend access from multiple threads. This makes it a particular precocious problem. Using of these methods also couples a lot of code to vectors such that it won't be easy to replace it with our different list implementations. Mm, So here we just see the vector is a class which is similar to the traditional Java array. Expect that it can grow as necessary to accommodate the new elements. Like an array, elements of a vector object can be accessed via indexed into the vector. The nice thing about using the vector class is that you don't have to worry about setting it to a specific size upon the creations. It shrinks and grows automatically when necessary. Vector implementations are dynamic array. It is similar to the array list, but with two differences. Because vector is synchronized, vector contains many legacy methods that are not part of the collections framework. Vector provides to be very useful if you don't know the size of the array in the advance, or you just need one that can change the size over the lifetime of the program. Now we just see the program of the vector in our Java data structure, which illustrate the several of the methods supported by this collection. So here I just import a library which is a name of java.util. We have the class name which is a vector demo, and then the main method which is public static void main and string arguments. Now I just initialize the size of the three incremental array. Vector v which is equal to new vector. So here the size of 3 and then the size of 2. Now system.out.println, and the print line here is initial size, and then plus v dot size here. Now here I just write system dot out dot print line, and the print line here is initial capacity, and then the initial capacity is v dot capacity, which is used in the vector. Now here I just write v dot add and add the elements. Then here I just write new, and new is integer here, and then it's 1. Now I just copy for 1 time, 2, 3. So it's 2 here, and then 3, and then 4. And now system.out.println, and the print line here is capacity after 4 additions. And then I just concatenate the capacity. So v dot add, and the add is an element here, and it's new, and then the data type which is double, and the value is 5.45. Now system.out.println, and the print line here is current capacity, which is the concatenation of v dot capacity. Here I just copy this code and paste it 1 time for the double, and then change the value which is 6.06, and here v dot add, and add is element here which is new and integer, and then the integer is 7 here. Okay, now v dot add, and v dot add element, an element which is equal to new, the data type is float which is 9.3, and then v dot add element which is new integer, and then the integer value is 10 here. System dot out dot print line, and the print line is current capacity, and then concatenate v dot capacity. Now here v dot add element, and this is add element, and now where new is integer, and integer here is 11. Then v dot add element, and new is integer, and which is 12. System dot out dot print line, which is first element, and then concatenate integer, and it's integer, and then v dot first element. So I just print the first element and then create the and then concatenate the integer, which is v dot first element. Then system dot out dot print line, and the print line here is last element, and then concatenate integer, which is v dot last element. Now I just used if statement. So if and v dot contains, so v contains new integer, which is, and it's integer which is 3, and then system dot out dot print line, and the print line here is vector contains 3, and here I just enumerate the element of the vector. So enumeration, and the enumeration which is v enum, and then which is equal to v dot elements. And now system dot out dot print line, and the print line here is slash n, and element is vector. So while v enum dot has more elements, which is check it's return true or it's return false. So plus, and then empty string, and system dot out dot print line, and the print line is null. So it's not a concatenation here, so I just write the while loop here, and then system dot out dot print line, and the print line is v enum dot next element, and then I just concatenate an empty string. Now I just checked the output for this code. So here you can see we have the initial size of this is vector is 0. Then we just define the initial capacity of the vector is 3. You can see here this is the initial capacity of the vector, which is 3. Then capacity after 4 addition is 5. You can see here we have the capacity after the 4 additions is 5. Then we have the current capacity, means after the 4 capacity we have the current capacity is 5. Then after that we have the another capacity which is 7, and then we have the another capacity which is 9 here, and then the first element I just printed which is 1. So this is the first element of the integer which is 1, and the last integer value is 12. Then vector contains 3 integers, and then first element of the vector is 1, 2, 3, 4, and then you can see a 1, 2, 3, 4, and then 5.45, and then 6.05. Then we have 7, 9.3, 10, 11, 12. So we have these element of the vectors which is the print here. So this is a simple example of illustrate a several of the method supported by vectors. I just tell you a simple difference between the array list and the vector. So in synchronization, array list is not synchronized, means which means that multiple threads can work on array list at the same time. For example, if one thread is performing an add operations on the array list, there can be another thread performing remove operations on array list at the same time in a multiple threaded environment. While vector is synchronized, this means if one thread is working on the vector, no other thread can get a hold of it. Unlike array list, only one thread can perform add operations on the vector at a time. So this is the vector in data structure. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be discussed about stack in Java data structure. A stack is logically data structure that can be logically through an linear structure and can be represented in the real life as a pile of plates or deck of cards. In this data structure, insertion and deletions of an items take place only at once of the end, which is called the top. Here you can see we have the three index which is 12, 37 and 99. So this is our top index which is on 12. So the basic concept can be illustrated by thinking of your data set as a stack of plates or books when you can only take the top item of the stack in order to remove the things from it. So the basic implementations of the stack is also called LIFO, means last in and first out. If I add 99 as a first index, so it will be out as a last index in the stack. So it is to demonstrate the way it access like last in and first out. There are basically three operations that can be performed on the stack. First one is inserting an item into the stack, which is called push. So here we have the index 12 and we just push it into the stack. Then the second number operation is deleting an items from the stack, which is pop. So we are just deleting this 12 from our stack. And the third number is displaying the stack contents, which are peek. So this is called peek here. So the stack class implements a last in first out stack of the elements. You can think of a stack literally as a vertical stack of the object. When you add an element, it gets stacked in on the top of the others. When you pull an element off the stack, it comes off the top. In other words, the last element you add to the stack is the first one to move needs to first one to the comeback of. A stack is a subclass of the vector that implements a standard last in first out stack. A stack only defines the default constructor which create an empty stack, and a stack includes all the methods defined by the vector and adds several of its own. Now we just see the example of a stack, and here we have the class which is stack, and here I just import a library which is java.util, and now I just write static void and show push. Okay, and then here I just write stack and st, and here I just write int a. Here I just open the block of code, so st and then push. So push is new, and new is integer which is a, and it's not a comma here, so yes, new, and it's st push. Now system dot out dot println, and the println here is push, and then I just write concatenate a, and here I just close this bracket. Now system dot out dot println, and the println here is stack, and then I just concatenate st. So here I just create the operations to show our push. Now static, and it's static void and show pop, and then stack st, and here I just write system dot out dot print, and the print line here is, and it's system out and the print line, and the print line here is pop, and then I just write integer a which is equal to integer, and then st dot pop, and this is st dot pop. Now system dot out dot println, and the println here is a, and then I just write system dot out dot println, and the println is stack, so this is a string here, and then I just concatenate st. Now I just define the main method, and the main method is strings and the arguments, and then stack st which is equal to new stack, and then system dot out dot println, and the println here is stack, and then plus st. Now show push, so here I just pushing the indexed which is, or a element which is 12. Then I just write show push, and the push here is st which is 50, and then I just write show push which is st and it's 66. Now here show pop means First, I just add 12, 50, and 60 as an insertion operator, and then here I just write delete for show pop and then st and show pop, which is st. Okay, now exceptions, so try show pop, which is st, and then here I just catch the exception, which is empty stack exception, which is E. And now system.out.println, and the print line here is empty stack. Okay, and now here, so here I just add a method or create a method to pop and push. Now I just run this code. So here the pop is null and the pop is null. At the initial stage, we have the stack which is empty. Then, sorry, at the initial state, we have add the value which is 42. Then we push the value which is 66 and then 99. Afterwards, here I just execute the value from the stack. So empty, stack is empty, and then the stack is empty. So these are the push, sorry, the pop means we just delete the values from the stack. Now here we just see the another example of dynamic stack in Java. So here I just write private integer stack size, then private integer and stack array. So here I am creating the example that the stack will never comes to the Stack Overflow case because its capacity will keep increased and it's reach to the maximum capacity. So it is very dynamic in capacity here. So integer and then take an integer as a top. So here I just create a constructor to create the stack with size. So public and my, so public and dynamic stack, and then I just write integer and size. Okay, and then here I just write this dot stack size, which is equal to size, and this dot stack array, which is equal to new integer and stack size. So here close with the semicolon, and this dot top, which is equal to -1. Now here I just write the method public void and push. So this methods add a new entry to the top, an integer entry. Then I just write if, and this dot is stack, which is full, and here and stack dot full, and then I just write system dot out dot print line, and the print line here is stack is full and increasing the capacity. Okay, now this dot increase, which is stack capacity. Now here and here I just write system dot out dot print line, and the print line here is adding and then entry, and it's a concatenation of entry. Now here after that I just write this dot stack array, and which is plus top, and which is equal to entry. Okay, now after that I just create the method, means this method to remove an entry from the top of the stack. So that's case I'm just writing integer, public integer, and then pop for the deletions, and then throws exception, and it's throws. And here I just write if, and this dot is stack which is empty, and then here I just write throw which is new exception, and here I just write stack is empty, cannot remove element. Now after that I just write int entry which is equal to this dot and this dot stack which is array, and the array which is equal to top minus minus, and then system dot out dot print line, and the print line here is remove entry, and remove entry. Okay, and then concatenate entry here. Now return entry, and after that I just create the method to return the tops of the stack without removing it, and our this method was for math for remove an entry from the top of the stack, but now we are just creating the methods to return the top of the stack without removing it. So public, long, and peak, and then return stack array which is top, and here I just write private void increase stack capacity, and integer, and then new, and new stack which is equal to new integer, and this dot stack size. So our stack size is multiplication of 2 here. Now for integer I which is equal to 0, and I which is less than stack, and then I plus plus. Now new, and new is stack here, and stack is I, and here it's a stack size, and I which is equal to this dot stack array, and array here is I. Now I just write this dot stack array, which is equal to new stack, and then this dot stack size, which is equal to this dot stack size. So stack size is multiplication of 2. Now here I just create the methods to return the true if stack is empty. So public and boolean, which is stack, and stack is full, and then return is top, which is equal to stack size, which is -1. And here I just write public static void main, and then string arguments, and then here the name of the class, which is dynamic stack, and here I just write stack, which is equal to new dynamic stack, and the value of it is 2. And now I just write for integer I, which is equal to 1, integer I which is less than 10, and then I plus plus means the increment operator, and then stack dot push, which is the entry of I, and then for loop again for integer I which is equal to 1, and I which is less than 4, and then I plus plus. So now the exceptions. So stack dot pop, and then I just catch this exception. So it exceptions E, which is to generate the catch block automatically. E dot print stack trace. Okay. So here I just create the method to this stack empty, and yes, I have no error in program, and I just run this program. So you can see here at the initial stage we are just adding the value which is 1 and then 2. So I just add 2 indexed, and stack is full, increasing the capacity. Then we are just adding 3 and 4. Then stack is full, increasing the capacity. So you can see here we just write that we are just enter the 2 size stack here. So after that it increasing the capacity, and then 5, 6, 7, and 8. So just double of the size of stack means, which is 4, 4 integers, yes. Then stack is full and increasing the capacity when, and then we just add the 9. You can see here it's up to 9. Then we just remove our entity which is entry which is 9, 8, and 7, because it is stack. So this is first in, then second number, third, fourth. So first in and last out, and last in, first out. So first of all I just execute 9, then execute 8, and then 7. So this is an example of the dynamic stack in Java. When we just listen or hear the word of stack, so example in our mind which is the towers of Hanoi. Now we just see the example and see what is the towers of Hanoi. The towers of Hanoi is the mathematical game or puzzles. It controls, it consists of three rods and a number of disks of a different size, which can slide into any rod. The puzzle starts with the disk in a next stack and ascending order of the size on the one rod. The smallest at the top, thus making a conical shape. The objective of the puzzle is to move the entire stack of the another rod, obeying the following rules like first of all, only one disk must be moved at a time. Each move consists of taking the upper disk from one of the rod and sliding into another rod on the top of the other disk that may already be present on that rod. No disk may be placed on the top of a smaller disk. Mean if a disk is bigger than another disk, so no disk will be top of the smaller disk. Now we just see the diagram of the Tower of Hanoi. As you can see, the rule number first, the one element on the disk must be moved at a time. Then each moves consist of taking the upper disk from one of the rod and sliding into another rod on the top of the other disk that may already be present on the rod. No disk may be placed on the top of a smaller disk. So here you can see we have the three step means the three step Tower of Hanoi. The first one you can see here, it's moved to the destination. This is our source, this is our destination, and this is auxiliary. So we are moving our this tower from source to destination. So this is the process. So here you can see the smallest element moved to the destination, then auxiliary, and then it's moved to destination, then source, and then destination, and then destinations. So this is the example of the Tower of the Hanoi. Now we just see the programming example of the Tower of Hanoi, and we solve it by using the stack. I just create a class which is a name of Tower of Hanoi. Now here I just write private and then static and write my or dynamic stack, then array, and then write tower. Now public static void and then Tower of Hanoi. And the Tower of Hanoi is integer, which is a number of n. So the any number here. Now I just create a three stack Tower of Hanoi. So I just write tower which is equal to new and this one dynamic stack and then the for. Now for and the integer I which is equal to 0 and I is less than or equal to 3, and then increment operator which is I plus plus. Now tower the array of I which is equal to new and dynamic stack and then element of 4. Now for integer t which is equal to n, so n are the numbers of this integer and d is greater than 0 and d is decrement operator. First I just create the stack of 3 Tower of Hanoi and then I just writing the decrement operator, and here I just initialize means add disk d to the tower number 1. So here tower is the 1 and then dot push, and which is new and integer, and d. Okay, now show tower and states which are n, 1, 2, and 3. So it's move n disk from the tower number 1 to the tower number 2 using 3 as a intermediate tower. Now I just write public static void and show tower states which are int n, int x, int y, and int z. Now if n is greater than 0, so it's 0, and exceptions are try, which are show tower states and n minus 1, and then x, y, z. Now here I just move d from tower x. So integer d, which is equal to integer which are tower x dot pop. And now I just move tower to the top of the tower y. So tower, not move tower but element, yes, y dot push, and here the entry is d. Now system dot out dot print line, and the print line here is move disk, and then concatenate d and plus from tower, and then I just write concatenations of x and to top of tower, which is y. Now show tower, which is states, and then n minus 1, and z, y, and x. Now here I just write catch, and catch is an exception, and its exception, which is ex. And after that I just write the main method, which is public static void main and string and arguments. Now here I just write system dot out dot println, and the println here is running 3 disk problem. Now here we just run our 3 disk problem, and tower of, and here it's tower of Hanoi. Okay, and these are the 3 disk. Now here I just create a class which is my dynamic stack. Okay, and here I just write private integer stack and the size, and I I just already write this class, so there is no need of writing this class again. So this is the dynamic class. Okay, So I just run this tower of Hinai now, and you can see first of all it is running the three disk problem. So I think this example is mixed with dynamic stack example. So, and here I just write the stack is full and increasing the capacity. It's the same here, and then system dot out. So I just remove this system dot out dot print line, and then pop integer means integer pop throw exception, and then throw same like this one. And here I just write just not right here, so long peak, and it's a return, and the return is the top here, and then the private, and then string and the size here. So now the boolean, and then the boolean size stack size, and add the last public static void, and now I just run this code. So new stack, so local variables, so the field here, and now just check. And yes, I just removed this one, sorry. Like we just remove entry, means from our first tower, means source to destinations, and then I just remove second one to the source to auxiliary, and then here after that I just write move disk 2 from tower 1 to the top of the tower 3, and then after that I just move disk number 1 to the tower of the 2 to the top of the tower 3, and then I just move disk number 3 from the tower number 1 to the top of the tower number 2, and then move disk 1 from the tower number 3 to top of the tower number 1, and move disk 2 from tower number 3 to the top of the tower number 2, and then move disk 1 from tower number 1 to the top of the tower number 2. So this is an example of the Tower of Hanoi with Java. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture we are going to be discussed about queue in Java. A queue is a container of an object which is a linear collection of the data structure that are insert and remove according to the first in and first out principle. In last lecture we learned about the stack, which is a concept of first in and the last out. So queue is the opposite to stack. An excellent example of a queue is a line of student in the food court. New additions to the line are made to the back of the queue, while removal or serving happens in the front. In the queue, only two operations are allowed. Number one is in queue, and number two is dequeue. So a queue is a kind of abstract data types or a collection in which the entities in the collections are kept in order, and the only operations on the collections are the addition of the entities to the rear terminal position, which is called in queue, and removal of entities from the front terminal position is called dequeue. As I told you, queue is a concept of FIFO, means first in and first out. So queue provides the services in computer science, which is a transport and the operations research where various entities such as data, objects, persons, or events are stored and held to be processed later. In this context, the queue performs the function of a buffer. So there are some operations what we do on the queue. First one is in queue. Here you can see we are just seeing watching enqueue. So enqueue means add an item into the end of the queue, which is tail. When we just add the items from the tail, which is called enqueue. Then it's front. So front return the item at the front of the queue. And you can see dequeue. So dequeue remove or delete the items from the front of the queue. Now we see overflow states. So a queue may be implemented to have a bounded capacity. If the queue is full and does not contain enough space to accept an entity to be pursued, the queue is then considered to be an overflow state. And what is queue underflow? The dequeue operations remove an items from the top of queue. A dequeue operations either retrieval previously cancelled items or return in an empty queue. But if the queue is empty, it goes into the underflow state, which means that no items are present in the queue. When no items are present in the queue, it is called underflow. And when queue is a full stage, so it's called overflow. Now we just see a simple example of the queue with arrays. Here you can see I just creating the package here, and then here I write queue array. Now here I just write integer, which is capacity, and the capacity which is equal to 2, and this is the private here. Okay, now I just write the integer for queue, and queue is array here, and then integer which is front, which is equal to 0, and then int rear, which is equal to -1. Now integer which is current size, which is equal to 0, and then here I just write public and queue array. So this is a constructor for our queue, means here I just create a default constructor for my queue. Now, and yes, now I just write queue and array, which is equal to new integer, and this dot capacity. So this is a copy and name, yes, it's okay. Now here I just define the method to add the element at the end of the queue. So that case I just write public void and in queue. Okay, so what is the in queue here? So you can see in queue when we just add the element through our tail. So this is called in queue, and dequeue when we just delete the element from it. So it's called dequeue. So in queue, and this is the parameters for our this method, which is item. And now here I just write if is queue full. So system dot out dot print line, and the print line here is queue is full, and increase capacity, and increase capacity, and then I just go to the rear where we just add the value. So it's a plus plus here. So now I just write if rear is greater than or equal to q array dot length, and here I am just using the AND operator, which is the current size, which is not equal to q array dot length, and here I just write rear which is equal to 0. So the initial value of the rear here is 0. Now q array and then rear which is equal to item and then current size increment here means the current size plus plus. Now system dot out dot print line, and the print line here is adding and then item. Okay, and here I just write q array and rear which is equal to item. So rear is a array here. So I will go to the another method to dequeue the items from our top of the queue, means to remove the element or an items from our queue. So public void dequeue, and if is queue empty, so system dot out dot print line, and the print line here is queue is under flow, means under flow means queue is empty here. So unable to remove element from queue, and here I just go to the else statement. If queue is not empty, then font is plus plus, sorry, the front is plus plus, and then if front is greater than q array dot length, so what will be the output? Length minus 1, and here I just write system dot out dot print line, and the print line here is removed and then plus q array which is our object, and here I just write front minus 1, and this is else statement. Now here our front is empty here, means front is 0, and then else system dot out dot print line, and the print line here is removed and then concatenation of q array and front minus 1. Now current size minus means the decrement operator, and now here I just create the method to check whether queue is full or not. So that case I'm just using boolean here, which is queue full, and then boolean which is status of the queue, means the status of the queue is empty or not. So here the status is false. So if current size which is equal to q array dot length, so q or array dot length here, and then the status which is equal to true. and then return status. Okay, and this is true here. So this statement will check if the queue is full or not. So now after that, I am just creating the method to check the queue is empty or not. Means if our queue is empty, so this will check. This method is checked by, so it's a boolean and is queue empty, and then boolean status, which is equal to false, and current size, so it will check the current size here, and then status, which is equal to true, and here I'll write return status. Now private void and increase capacity, and then in this method I just write, so I just create a new array with the double size as the current one. So an integer new capacity, and capacity which is equal to this dot q array dot length, which is multiplication of 2, means we just taking the array size double, and then integer, and integer is an array of new array which is equal to new, and integer is new capacity. Here I just write integer which is temp front, and which is equal to front. So this element will copy to the new array, means the copy from rear to front, and integer index is also copy the rear from front, so here index is -1, while true, and then here I just write new array which is concatenation of indexed, and this dot q array, so the array elements are temp front. Okay, and here I just write temp front which is equal to 0. So temp front, so I just concatenate this front here, and then I just write if conditions for temp and temp front which is equal to this dot q array dot length, and then here I just write temp front, so it's a tmp temporary front, and which is equal to 0, and here I just write if condition, so if current size which is equal to indexed, and index is add one element with it, so break statement here, and after this break statement I just make a new array in the queue, so this dot q array which is equal to new array, which is system dot out dot print line, and the print line here is new array capacity, and then this dot q array dot length. Now I just reset all the values from the front and the rear, means all the value from the tail and the head. So this dot front and this dot rear, which is equal to 0. So not rear equal to 0, it's rear equal to indexed. Okay, now we just come to the main method to define. First of all, I just create an object to it. So this is the Q array, and now, sorry, it's here, public static void main and string arguments, and then Q array and Q, which is equal to new array. So I just create an object, so I just call object for enqueue, and here I just write the item which is 4, mean I just add the item which is 4, then q dot enqueue, and here enqueue is empty. I just not add any item here. So after this enqueue, so I just write q dot dequeue, means I just add this for and execute this for. Now here in the enqueue means add 56, then q dot enqueue, and here I just add 2, then q dot enqueue, and I just add 60, then q dot enqueue, and I just write 24. So after this 60, I just write q dot dequeue, so I just execute one another element again, means here I just add 4, then I just dequeue this add, so it will go to the this stage, means this index, and then I just add 56, so 4 is here, then I just add 2, 4 is here, then 60, then 4 is here, then I just dequeue, so 4 has come to this stage, and now we just see the 24, and then q dot enqueue, which is 98. Now q dot dequeue, q dot dequeue, and q dot dequeue, so I just execute 3 index again, and then q dot enqueue, and I just add one another element which is 300, and then q dot dequeue and q dot dequeue, and execute 2 more elements. Now we just see the output. So here I just write change is q to empty, and then execute it. So here you can see, first of all, I just add 4 in our queue, then 4 removed from this queue. You can see here 4 I just add here from the tail, and then 4 is removed. Then the 4 is removed from the queue. Then we add the 2 elements here, which is 56 and 2. So here you can see I just define the capacity of the 2. So the queue is full here, now increasing the capacity. Now the array size is double here, where you can see this statement like integer new capacity, which is equal to this dot array, sorry, this dot q array dot length multiplication of 2, which is 4 now. Now here you can see that I just add the 4 here first, and then 4 removed from this, then I just add 56 and 2, so our queue is full. So now it is increasing the capacity. So new array, which is the size of 4. So we have 1 2 3 4, so I just add 60, 56, 24, and 98. Then I just remove 2 from here. You can see I just add here 2, means we have the two size of array, this one and then 4, 1, 2, 3, 4 size. So we have the total elements are 2. Then I just remove 2 and then 60. Then I just remove 24 and then I just add here the value which is 300 and then I just remove, means dequeue this 98 from this queue, and then at the last I just remove this 300 from our queue. So this is the example of the dynamic queue implementation using array. So a queue is a kind of abstract data types or the collections in which the entities in the collections are kept in order to in order, and the only operations on the collections are additions of the entities to the rear terminal position, which is called enqueue. Means here the rear is enqueue and the front is dequeue. Front is dequeue. Now we just see the example and we just see the double-ended queue where we can delete or insert both the side of the queue. Let's see. So this is the example of the double-ended queue in Java. You can see here we can delete from this side, means delete from front, and the delete from rear, and we can insert from the rear and insertion from the front, means here insertion or deletion from the in queue and insertion or deletion from the D queue, means tail or head. So what is the ended double-ended queue, means DQ? A double-ended queue or a DQ is an abstract data type with generalized a queue for which elements can be added to or removed from either the front or rear. DQ means DQ is differ from the queue abstract data type or first in first out data type, where elements can only be added to one end and removed from other end. This journal class has some possible subtypes, which are an input restricted DQ is one, where deletion can be made from another both the side, but insertion can be made with one end only. Means we can delete both the side, but insertion from one side only. An output restricted DQ is one where insertion can be made at both the end, but deletion can be made from one end. Means in our double-ended queue, we can insert or delete the value in both ends. So you can dequeue a stack by making insertion or deletion at the same side, but you can use dequeue as a queue but making in setting elements at one end or removal element and other end in our queue. Now we just see the example of this dequeue in Java. So here queue and the class dequeue, and here I just write private and list and then integer, which is dequeue, which is equal to new and array list and integer. So integer here. Okay, so this is an object, so private list and the dequeue, so I just write here dequeue1. Okay, and now here, so first it's not taking the list here, so I just import a library which is java.util and util.array list. First one, so it will take the array list here, then import java.util and its list here. Okay, and this will take this list. Okay, now I just write public and void insert front and then integer which is item. Now here I just write, so it's the insert front. Okay, now I just add element to beginning of the queue, means we just add element in the beginning of the queue. So print line, and then here I just write adding at front, and then I just concatenate item here. Okay, and here I just write dq1 dot add which is 0 and item, and then here I just write system dot out dot print line, and the print line here is dq1. Okay, and this is our dq1, or I just change with dq. So here I just write array list. Okay, so here I just not add the body, so that was making the error in the program, and then it's a dq here. Okay, now here I just write public void and remove. So remove is a font here. Now if dq dot and dq dot is empty, so system dot out dot print line, and the print line here is dq is under flow, unable to remove, means you can not be remove the index or items from this dq. So return here, and then here I just write integer remove which is equal to dq dot remove, and the value of the remove here is 0. So it's dq. Okay, so this will remove an item from beginning of the queue from here. Now system dot out dot print line, and the print line here is removed from front. Okay, and then plus remove means this integer, concatenate this in integer which is rem, and remove which is dq, and then we just go to the public and void remove rare, and if dq is the empty, so system dot out dot print line, and the print line here is dq under flow, unable to remove, and return, and here I just write integer, and integer here is rem, which is equal to dq dot remove, and here the item is index dot size. So size is minus 1 because I am just dequeuing the value from it. So it will remove the items from the beginning of the queue. So system dot output message here is, so the message is removed from front, and then plus rem, and then system dot out dot print line, and the print line here is dq. Okay, and here after that I just write public integer and peak, which is front. So this is our peak point, which will get the element from the front without removing it. So item, which is equal to dq, and dq is get, and get value is 0. Now system dot out dot print line, and the print line here is element at first, and then plus item, and now return. So return is the item here. Now public integer and peak for the rear means to add, or so here in this method I just get the element from the rear without removing it, and item, which is equal to dq dot get, and it's dq dot size, and the size here is minus 1. Now system dot out dot print line, and the print line here is element at rear, and plus item here, and then return. So it will give us the return value, which is item. Now we just come to the main method and define create an object and call the object for each enqueue and dequeue. So main and string arguments, and here I just write the name of that, so it's dequeue, and so create an object to my this class. So dequeue, which is deq, which is equal to new and dequeue. Now dequeue dot insert front, which is 34, then dequeue dot insert front, which is 50, and dequeue dot delete front means remove dot remove front, and deq dot remove front, and then deq dot remove front. So yes, I just removed 3 front, and now deq dot insert front, value is 21 here, and deq dot insert front, so value is 98, and deq dot insert front, which is the value of 50, and deq dot insert front, which is the value of 43, and deq dot remove front. Now here, and here I just write capital I, and did one other mistake, which is the colon here. Now I just run this code. So First of all, I just add a value in the front, means value from this one, so which is 34. Then add from the front is 50. Then remove from the front is 50 and 34, and then it's 34. Now our queue is empty in this stage, and then dq is under flow, means dq is empty here, mean we just come to the this stage. Now I just write adding at the front, which is 21. So adding the front here is 21, then adding at the front, which is 98, and we have the two value which are 98, 21. Then I just add 50 in the front, so 98, 98, 21 and 50 here. Then I just add 43, so the queue is going to 21, 98, 50 and 43. Now I just remove 43, means I just delete this 43 from this side, so it will execute 43. Then 50 comes here, 53, so 98, 50, sorry, 98 and 50, so 98 comes here, and then 98 will delete, and then at the last 21 will delete in this queue. So this is the example of DQ, means double ended queue in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be learning about the hash table in Java. Before proceeding with the hash table, we just need to know what is hashing. So the algorithm that calculates a fixed size bit value of a given resource, means a block of data. It's called hashing. Hashing is transformation of a string of characters into a usually shorter fixed length value or a key that represent the original string. Hashing is used to index and retrieve items in the database because it is faster to find the item using the shorter hash key than to find it using the original value. So hashing is also a unidirectional process too, so you can never work backward to get back the original data with it. Hashing functions that does not do this is considered to have the poor randomizations, which would be easy to break the hacker. A hash is usually a hexadecimal string to several characters. A hash algorithms can only be considered good and acceptable if it can offer a very low chance of collisions. Then here why we need hash algorithm. If you are transferring a file from one computer to the another computer, how do you ensure that the copied file is the same as a source file? One method you could use, which is called hashing, which is initially a process that translates information about the file into the code. Two hash value of the original file and its copy can be compared to ensure that the file are equal. Here I tell you what are the benefits of the hashing. One main use of a hashing is to compare two files for equality. Without opening two documents files to compare them word for word, the calculated hash value of these files will allow the owner to know immediately if they are different. Hashing is also used to verify the integrity of a file after it has been transferred from one place to another place. Typically, typically in a file backup program like synchronization back. To ensure that the transfer file is not corrupt, a user can compare the hash value of the both files. If they are the same, then the transferred file is an identical copy. How many types of hashings in Java? There are many different types of hashing algorithms such like Tiger, XX hash, and more. But the most common types of hashing used for file integrity checks are MD5 and SHA1 and SRC32. MD5 hash functions encodes a string of information and encodes it into the 128 bits like fingerprint. One like MD5 is often used as a checksum to verify data integrity. However, due to its age, MD5 is also known to suffer from extensive hash cohesion, and but it is still one of the most widely used algorithm in the world. SHA1 is developed by the National Security Agency like NSA. It is a cryptographic hash function. Result from SHA1 are compressed as a 160 byte hexadecimal number. This hash function is widely considered to successor to MD5. Now we just come to the SRC32 hash function. A cyclic redundancy check means SRC is an error detecting node often used for deletion of the accidental change to the data. Encoding the same data string using SRC32 will always result in the same hash output. Thus, CRC32 is sometimes used as a hash algorithm for file integrity check. Now we just see the hash table. Hashing is a technique that is used to uniquely identify a specific object from the group of similar objects. Here are some examples of the hashing which are used in our life. First one is in a university, each student is assigned a unique roll number. You can know that. So that can be used to retrieve the information about them. In libraries, each book is assigned a unique number that can be used to determine information about the book, such as its extract position in the library or the user it has been issued to it, etc. In both these examples, the student and the books are hashed to a unique number. Assume that you have an object and you want to assign a key to it to make searching easily. To store the key value pairs, you can use a simple array like a data structure where key integer can be used directly as an index to store the value. However, in this case there where the keys are large and cannot be used directly in the index, you should use hashing to it. In hashing, large keys are converted into the small keys. Like you can change the string into the keys. So for that purpose, we are using the hash functions to it. The values are then stored in a Java data structures, which is called the hash tables. The idea of the hashing is to distribute entries keys values pair uniformly across an array. Each element is assigned a key, which are converted key. By using that key, you can access the element in O one time. Using the key, the algorithm hash functions compute an index that suggests where an entry can be found or inserted. There are two ways to implement the hash. First one is an implement is convert into an integer by using a hash function. This element can be used as an index to the store the original element which fall into the hash table. The second number is the implement is stored in the hash table where it can be quickly retrieved using hash key. Hash key, which is what is a hash key here? So it's hash which is equal to hash function, and which is the function key here. So this is the hash function here. Then you can write the index, which is equal to hash, and then the modulus of array size. Okay, so here I'll just tell you what is hash function. A hash function is any function that can be used to map a data set of an arbitrary size to a data set of a fixed size which falls into the hash table. The value returned by a hash functions are called hash values, hash codes, or hash sums, or simply hashes. Here a term used which is hash map and hash tables. What is hash map? Hash map is a map based collection class that is used for storing the key and values pair. It is denoted by hash map, which have the key value, or like map hash map, which is key value of like here k and v. It does not sort the stored key and the value. You must need to import java.util.hashmap library in it, or it is superclass in order to use the hashmap class and the method. Now the question here is, what is the difference between hash map and hash table? Hash map and hash table both stores key value pair in hash table. When using a hash table or hash map, we specify an object that is used a key and the value that you want linked to that key. The key is then hashed, and the resulting hash code is used as an index at which the value is stored within the table. Here we have an example of hash map and hash table. So here, yes. So here you can see we have the data here and the hash function here. Our data name is Foxed, and we want to send this file to our this customer. So for security reason, and we just maintain our integrity in here. So that case, I'm just using the hash function for it. So from that data, it will make a key through hash functions, and then it will send through the cloud network to our user, or where we want to send that data. You can see here this is a text, then it will change to the hash with the help of the hash function, and it will make a hexadecimal key. It will use MD5 algorithm to it, or SHA-1. So that will make the key to the hash functions, and then it will decrypt that document and send it to the media. Here we have one another example of this hashing. So we have the keys, then we have the table and the key value pairs. So what does hash do here? So this is the key. So with the help of hash functions, we just make that key to the uh, with the help of that functions, we just make this key, this data from key, convert data from key. So you can see we have the Sam Taylor, and then the key of the Sam Taylor here is 48625 and 13. So this is the hash function. Now we just go to the example of the hash table. So first of all, I just import a library which is java.util, and now I just come to the main method. So public static void main, and then string and arguments. Okay, now here I just create a hash map first. So here I just write hash table and balance, which is equal to new hash table. So I just create a hash map, and then enumerate. So enumerations, which are the names here, and then a string, which is the str. Now here I just write double, which is bal, and this is a variable of the bal here. Now here I just write balance, so the variable here is balance. Okay, so not a variable, it's an object which is balance. So balance dot put, so put is a method here. So here I just write my, and my name here is Fayaz. Okay, and then we just go to the new, and here I just write double, and then 3256 point this value. So the value to my name here is this one, 3256.56565. Now balance dot put, so put is a hashable key here, and he just want the key, so I just write Khan, and then the value. So the value here is new and double, and then 156.23. Now balance dot put, so it's balance, which is an object here, and then put, and here I just write Daisy. Okay, and which is new and double, and 20232.65, so 65. So I just remove this, so 60. Okay, because it's a double here. So we also give minus value to it. So here I just write a name which is flower. So flower here, and then now I just write double, and the new, which is double, and the value here is minus 20.09. Now I just show all the balance here in the hash tables. Now names, which is equal to balance and balance dot keys. So here I just use this double with the capital D and D and D. Okay, now this is for hash table to show the balance in hash table. Okay, now it's a balance here. Okay, so I just use while loop, and then names dot has more elements, and then str, which is equal to a string, and it's a string, and then which are names dot next element, which is enumerations here. Now system dot out dot print line, and the print line here is str plus, and then here is a string, and the plus concatenations of balance. Okay, so balance dot get, and balance dot get, so this is an object key which I just passed the parameters as a string. Now system dot out dot print line, and the print line is empty, and now here I just deposit 1000 into the Fayaz string, this one. So here I just write balance, balance, and balance, which is equal to double, and here I just write balance dot get, and the get here is Fayaz. So dot and then double value, and now here I just write balance dot put where Fayaz is new and double, and then balance, which is additions of 1000, and here system dot out dot print line, and the print line here is Fayaz new balance is, and then concatenate balance dot get, and here I just write Fayaz, and here I just copy this curly bracket, and here I just write balance and the value here. Okay, and here I just did a little mistake, so I just write balance, and here we have the double variable as a bal. Now I just run this code, and we have an error here, which is I just write a balance here, and this is also a variable of the double, and now I just run this code. So you can see we have the flower value, which is the always on top, and it's a minus 20, then Khan value, and then we have the Fayaz value, and at last the value of the Daisy. So this is a smaller value, then higher, higher, and higher, and at the last the value with the double balance, which is 4256. Here I just create one another program to demonstrate the difference between the hash map and hash table. So class here, class name. So I just write the class name, which is test, and here I just import java.util, import java.lang, import java.input output library. Now I just go to the test class, and here I just write public static void main, which is our main method. Now here I just write the code for hash table. So hash and then table, and this is integer and strings. Now ht, which is equal to new integer and a string. Okay, so this is hash table, and I just create an object to my hash table. Now here I just write ht dot put, and the key here is 120, and the value is Fayaz, and yes, it's Fayaz. Now here I just write ht dot put and 200, and then Khan. Okay, and here I just forget to write hash table. Okay, now here I just write the print statement, so system.out.print, and here the print line is hash table. Okay, and then I just go to the for statement and write a keyword which is map, entry which is K, and V. So I just write here, I just remove this one, and then here just I just write m dot ht, which is our object name, and then here I just write dot entry, which is set here. Okay, now I just write system dot out dot println, and the println here is m dot get key, and there's m dot get key, and then concatenation of m dot get value K and V. Now I just write the code for hash map. So integer, and then a string, and integer and string which is hm, which is stand for hash map, and new hash map, integer and string. And now I just write hm dot put. So here the integer is 100, and then it's a daisy, and then hm, and then put, and the put here is 101, and the string here is daisy. Okay, so we have the value which is duplicate here. So now I just write whm dot put, and the put here, sorry, I just write the put all. So put, and then 102, and here I just write flower. Okay, now system dot out dot println, and the println here is hash map. Okay, and after that I just write for loop, and here I just write map dot entry, and the entry here is m hash map dot entry, which is set. So this is an entry of values and the keys. So system dot out dot println, and the println here is m dot get key, and then plus, and then concatenation of m dot get value. Okay, now I just check the output for this code. So I just run this code, so you can see the hash map which allows a duplicate value here. And now you can see here I just write ht dot put, and then here I just write 120, and the value here is Fayaz, or I just write 121. So 120 is better. So you can see an exception, and here I just write flower, and here I, yes, I just forget to write the semicolon here. So you can see hash tables cannot take the same value, it's just execute only the one value from these two. And here you can see the hash map takes allows the duplicates values. So the what are the difference between the hash map and the hash tables? Hash map is non-synchronized, it is not thread safe, and cannot be shared between many threads without the proper synchronization code. Whereas hash table is synchronized, it is thread safe, and can be shared with many threads. Hash maps allow one null key only and the multiple nulls value where hash table don't allow any null key or value. Hash map is generally preferred over hash tables if thread synchronized is not needed. So why hash table does not allow null and hash table hash map does? To successfully store and retrieve object from a hash tables, the object used as a key must implement the hash code method and the equal method. Since null is not an object, it cannot implement these methods. Hash map is an advanced version and improvement on the hash table, which is hash map was created later. So this is the example of the hash table and the hash map differences. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture. And in this lecture we are going to be discussed about the property class in Java. Properties are a subclasses of the hashable. It is used to maintain the list of the values in which the key is a string and the value is also a string. The properties class is used to many other Java classes. For example, it is the type of object returned by system.getProperties when obtaining environmental values. Properties define the following instance variables. This variable hold a default property list associated with a property object. Properties is a file extension for files mainly used in Java. Related technologies to store the configurable parameters of an application. Java properties files are amazing resource to add the information in Java. Generally, these files are used to store static information in key and the value pair. Things that you do not want to hardcode in your Java code goes into properties file. The advantages of using property file is we can configure things which are prone or to change over a period of a time without the need of changing anything in the code. Properties files provide flexibility in terms of configuration. Simple properties file is shown like here I just write this is property file having my configuration. So here I just write file name which is equal to data.text. Here we have the file name which is the extension of data.text. So each parameters is stored as a pair of string. Means the left side of equal sign is to store the name of the parameters called the key and the other is storing the value here. Means this is storing the key and this is storing the value here. So here is a code of the properties and here I just import a library which is java.input and output dot file. So it's a file input stream. Okay, import java dot input output and input output exception and its exception. Now here it's time to import java dot util and properties. Now I just go to my class which is prop and here I just define my main method. So public static void main and string arguments. Now properties, which is the object of prop, which is equal to new properties. Okay, so after that I just use the exception. So try, which is prop dot load, and load, which is equal to new, and file input stream. Then here I just write my config dot properties. Okay, so this is the load property file for reading the data. And now I just write property dot list, and the list is system dot out. Yes, so this will get the properties as the print, and this is the system here. Now as write system dot out dot println, and here I just write property dot, sorry, it's property dot get property, and here I just write file name. So this is for reading the each property values. So now I just define this for system.out.println, and the println here is property dot get property, and here I just write author name. These are the two properties here, which is a name, first one, and then the author. Now here system.out.println, and the println here is prop and dot get property, and here I just write topic. Okay, so we have the three properties here, and now I just write catch, and here I just in the catch I just write input output exception, because I am just catching input output exception here, and here is write ex and exception, which is ex. Now here I just write ex dot print, and print is stack trace. Okay, and this is exception. Okay, now now I just run this code, and you can see here we have no file present in the default project root location. We will get an exception like this one. We can provide a fully qualified path of the file as well. So this is the program to use the load method to retrieve the list when the program is executed. So it will retrieve the list when the program is executed. So it first tries to load the list from the file, which is called my configurations and the properties. If this file exists in our project file, so this list is load like means this list is load, otherwise it will input output expression will be thrown like this one. You can see this is the input output expressions to thrown to us. You can see here Java input output and file not found exceptions, which is my configurations and the properties. If you add the file in your program locations, means the project location, that then you will get that file answer. You can see here. So here we used get property method, and this is the get property method. Okay, so why we use get property method? One useful capability of the property class is that you can specify a default property that will be returned if no value is associated with a certain key. For example, a default value can be specified along with the key in the getProperty method, such as getProperty name and the default value. So this is the getProperty name. Okay. So if the name value is not found, the default value is returned. Means this value is not found. So then our default value will give us the return. When you construct a properties object, you can pass another instance of a property to be used as the default property of the instance. This is an example of property file in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we will walk through from the array list in Java data structure. The array list class is an array-based implementation of the list interface. Especially all elements of an array list are stored in a Java array. For example, an array list name word has its underlying array of the size like n. At this time, word is capable of storing at the most n elements. So what will happen if we try to add n plus 1 elements to the words? We will answer it after taking about the common operations using array list. Here we have an example of the array list, and here I just import a class which is library which is java.util. We have the class name which is ArrayList, and here I just define the public static void main, and this is our main method and strings and arguments. Now here I just write array and the array list. So I just take array list as a string, and then I just define the object to it which is list. So new array and list here, and then I just write string, and so I just create the array list here. Now I am just creating the list of an array, so add, and here I just write the array list which is Fayaz. So I just add an object in the list which is the name of Fayaz, and list dot add, and here I just write Khan. Okay, now list dot add, and here I just write Daisy. Now here I just use list dot add, and then here I just write Fayaz. Okay, now I just traversing list through the iterator. So iterator which is itr is equal to list dot iterator. Now I just use while loop, and iterator dot has next boolean iterator, and then I just print this array. So system dot out dot println, and the println here is iterator dot next. So I just print this iterator, and now we just see the output for this code. So you can see the output here. So here in this example we just create an array list here after this main method, and you just add the object in the array list, and then we just traverse the list through the iterator. So the array list class use a dynamic array for storing the element. As you can see here, it's intent the object the abstract list class and implement the list interface. Here's some key point about the array list class. So in Java, array list class can contain the duplicate item here. You can see Fayaz and the Fayaz. And the Java array list class maintain insertion order. You can see here we have the insertion order. So the array list class is not synchronized. So it is cannot synchronized, and Java array list allows random access because array work at the index base. You can see here in any array when you declare array, so it is work on the index base. So Java array class manipulations is slow. Here you can see array class manipulation is slow. A lot of shifting needs to be occurred if any elements is removed from the array. If we want to add remove any of the elements from this array, so we just do shifting for that, which is too slow. Let's discuss about the CRUD operations on the array list, means create, retrieve, upgrade, and delete. Let us write some example code using array list class. So here I just write class and CRUD array list. Okay. So to use the array list, the concept of the generic programming is needed here. Simply speaking, you can think of the generic programming as working with a journal type of T, like this one, where T can replaced by any Java types such as integers, float, string, or even object. Note that array list and the array list T are different here. The former is equivalent to the array object. In the content of this lecture means I just speaking, array list always refers to the latter generic version. Later in this series we will learn about the generic programming too. As array list was designed to be generic, you must specify the type of the element that will be stored. For example, the declaration of an array list named word whose elements are of types of string. Here you can see it's an array, and array is a list here. Then I just write string and word. So words which is equal to new array list, and then I just write string here and then close this code here. So we have the array list and then string words and which is equal to new array list. Since the word object is intended to be used as a list, so here we use this words object like a list. It is advisable to declare the word to be of types list string. Remember that you all through declared as list, the word object is still an array list. So here we have another. So here for that you can need a polymorphism concept. So I just write a words dot add, and here I just write Fayaz, or I just write word. Okay. So now here word is the, so I just write Fayaz, so it's better now. So we write word dot add Fayaz. So now word is Fayaz here. Remember that the words can only hold elements of the type string. If you try to add a double, so then you write words dot add and here like 2.0. Okay. So if you want to insert a string at the index 0, so you can write like words dot add and then 0 and here is string. Okay, so the word is now here is a string, and the word is here is Fayaz. You can see here we have the two words here. Now, if you want to access an element via indexed, so you can write like a string w, which is equal to words dot get, and then you can write 0. So you can get here means you can access an element via indexed. So now we just see example of that CRUD array list. So for that I just import a library which is import java.util, and it's java.util and array list. Now again I just write import java.util, and util is the list here. Okay, and it's a list here. Now I just define my main method, so public static void main, and then string arguments. Here in the argument I just create an object which is a string, and we have the string object which are words, okay, which is equal to new and array list, and then a string. Okay, so before that main method we just need to write public static void and print list. So here I just pass list, which is a string here, and then words. Now I just use for loop. So for integer I, which is equal to 0, and I is less than words, sorry, words dot size, and here I just write an increment operator. Now I just write system.out.println, and the println here is words, and then I just concatenate I here, and then I just close this code. So now here I just write words dot get, and get is I. So I just write a semicolon here, so I just remove this semicolon, and now just go to the main method. Now here we just append the word, so words dot list. Okay, and now here I just write college. So our word is now a college here, and this is a capital list L for a list, and this is also a capital list. So now you can see our word is, so it's add here, not a list. So our word is the school, sorry, a college here. So here I just write print, and the print is a list here, and then now I just write words, and then I just write words dot add. So we have the index 0, and I just write at. So we have two words now, which is college and add, and the index is 0 now. Now system dot out dot println, and the println here is insert via, sorry, it's via indexed. Okay, and now I just write print dot list, and list is the words here. Now after that I just write, So it's a print list, not print dot list. Okay. So after that, I just write words dot set now, and now we have the index number one, and sorry, we have the index number one, and the element here means a word here is work. Okay. Now I just write system dot set, sorry, system dot out dot print line, and the print line here is update via indexed. Okay. And afterwards I just write print list and then words. So we just delete an indexed, sorry, we just update an indexed here, so it's words. And now first we just insert a index, a word at the index 0, and then we just delete, sorry, we just update the index, and then we just remove the indexed. And here is right remove, and the index is a 0 here. Now we just removes from the word at the 0 and the print line, and here is right remove via indexed, and here is right print list, and it is a words. Now I just check the output. So first of all, you can see here we just add a 0 index, a word on the 0 index, which is college. Then here a insertion print out is called, so insertion via index. Then the word on the index 0 and at, so this print statement will printed. So now we have the words which is on index number 1, and the word here is college. Now we just update that index. So we just take a 0 index at, and then we just update a word which is work, which is on index number 1. So this college is update here. Now we just remove via index number 0. So I just remove this work. So this is example of the array list with create, retrieve, upgrade, and delete. I just use a word in this lecture which is a generic programming. So what are the generic programming? Generic are the kind of functions for a variable and its type. Normally you make a functions for a task that you do a lot of, or instead of having to repeat the same code over and over again, you let the compiler and computer to do that behind the scenes for you. Generic do the same thing. Expect for data structure, let's say you want to make a linked list of 10 integers. Then later you want to make a linked list of a string. In the most languages, mostly in Java, this means a lot of the same code gets repeated twice. And this means twice a much typing. And that there is twice as many places you can make a typo that break your program. Not so good means this lab generic programming is not so good. Even object oriented programming is better than generic programming, because we just create an object in the object oriented programming and we have the code reusability. But when you make a generic type, you tell the compiler that this is how you make a linked list. Then when you want a linked list of an integer, you tell the compiler make a linked list of an integer. Then when you want to want a linked list of a string. Then you tell the compiler to make me a linked list of a string, and it does all the work while you get on with your life with probably most coding. There are also things called generic functions. There, these are the functions for a variable's type that are also functions for a variables. What is mean is that you define a generic function by telling you a compiler, this is what I want you to do with the data I put in the function, but without telling it a lot about the data itself. That that's why you when you want to use the generic functions is declare it's reduce what you want to do with the data and does the work to try to get the function to work correctly behind the scene. So this is the generic programming here. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we will talk about the linked list class in Java. So before going to the example of this linked list, we just need to know what is the actual linked list class do. So Java linked list class uses the doubly linked list to store the element. So when we just store an element in the linked list, so we just simply use the doubly linked list. It provides a linked list data structure. It inherits the abstract list class and implements the list and dequeue interfaces. Like we have the iteratable here, then collections, and here I just define a list and queue. Now abstract, sequential list, and then dequeue. Okay, and afterwards at the last I just define link list. So what does actually do here? So this link list extends from our abstract sequential list, and it will implements through dequeue and queue, and then it will go forward through extend and extends implements through list. Now we use extend keyword with our collections, and the collection is also extends from iteratables, like iteratable extends from collections and collection extends from list and dequeue. Then when we go through the list to abstract sequential, so we just implement this, and when we go through the queue to dequeue, so we just use extends keyword, and then dequeue to linked list, so here we just used extends and implements. So now we just need to know some important points about Java linked list. Java linked list class can contain duplicate element. Java linked list class maintains the insertion order. Java linked list class is not synchronized. Remember that. It is the not synchronized class. In Java, linked list class manipulations is fast because no shifting needing to be occurred. Means you can not be shifting anything in Java linked list class. So it is fast. Java linked list class can be used as list, stack, or queue. I just told you that queue and dequeue. So you can use this class as a list, stack, or queue. So what is the hierarchy of linked list class? So you can see here this example. So Java linked list class extend abstract sequential list, this one. So it will extend this list, means linked list through extend, and it will extend abstract sequential list class and implement list and dequeue the interface, means when we just use implement, so we just using the interface here, so it will dequeue through the interface. So what is the actual declaration of Java linked list class? So here I just use a simple code for Java linked list class. So this is linked list, and then I just use here E. So it will extend from abstract sequential list and list, and then sorry, it implements list E, and then here I just write dequeue, which is E, and then serializable. Okay, so what we do here, we just take a public class which is linked list, extends from the abstract sequential list, and then we just implement this class through the list, and then dequeue serializable. So after the serializable, I just use one another thing which is clonable. So what is clonable here? Clonable means when you just take some elements or some features from another class. So this is called clonable. Now we just go through the actual example of linked list. Here I just import a library which is java.util, and then we have the class name which is linked list. So I am actually writing an example here for book. So I just take an integer as an id, a string name, we have the string which is the name of author, and name author and publisher. Now we have, I just take integer, and the integer which is quantity, and it's quantity here. Then I just use public and linked list, and here we have the class name, and then integer which is id, and string name, string author, and string publisher. Then integer which is quantity. So I just take a class name as a public which is linked list, and then I just pass an integer, string name, string author, string publisher, and string quantity. Now I'm just using this keyword and this id which is equal to id, this dot name which is equal to name, this dot author which is equal to author, and this dot publisher which is equal to publisher. and at the last this dot quantity, which is equal to quantity. Okay, so the question here is why we use this keyword with this dot id, this dot name, this dot author, publisher, and quantity. So as you know that this keyword can be used to refer the current class instance variable. So it can also be used to invoke the current class method and the current class constructor too. And it will pass as an argument in the method call. So we just come to our example here, and I just create a class name which is, so here I just, sorry, here I just take a package here which is linked list 1. Okay, and where's my class which is linked list, and yes, this one. So I just add this class to my linked list 1. Okay, so here I just create one another class name which is linked list example. Okay, so now here what we gonna do, here I just create the main method public static void main string and arguments. Okay, now here I just create the list of the books. So list which is book, sorry, book, and then here I just write list which is equal to new and linked list. Okay, and this is also book here. So this is list. Okay, so it will not take this book value because here we just create a class name with the book. So we have the already the class name which is linked list. So I just call this class here and linked list. Okay, now here I just create the book. So linked list and L1 which is equal to new linked list, and then here I just define the number which is 200, and then the string which is book. So Java had first, and the author name, so I just simply write the author name which is Fayaz. I'm not the right author for this Java book. And then we have the publisher, so any publisher here ABC, I just write the publisher name, and then I just write the quantity which is 10. Okay, now I just copy this one and paste. So we have another linked list which is L2 and 201, and head first Java, publisher which is Khan, and sorry, the author Khan, and publisher ABC, and the book quality is 20 here. Okay, and now we just go to the adding books to the list, means we just add books in the list. So here I just write list.add, and where here we have L1. So I just call object here, and then list dot add, and the arguments here means the parameters here, which is L2. Okay, now we just traversing our list. So why we traverse our linked list? So traversing the list of a doubly linked list can be in either directions. In the fact, the directions of traversing can change many times. If desired traversal is often called iterations, but that choice of terminology is unfortunate, for iterations has well-defined semantic example in mathematics, which are not analog to traversal. So we just use this traversing for the directions. So here I just use for loop and for linked list, which is L and then list. Okay, and here I just write system dot out dot print line, and the print line here is L dot id, then the empty string, and here I just use the plus sign here for concatenation, and L dot name, and then I just write L L dot author, and here I just write L dot publisher, and at the last L dot quantity. Okay, so now we just check the output for this code, and here proceed. So it will give us the error that our parameters are not generic. So for that, I just simply mouse hover on this linked list and just import the linked list java dot linked list library. Click here and run. You can see here the output, which is 200 java head first, and then author name is Fayaz, publisher is ABC, and the book quality is 10. Then 20 java head first java Khan ABC, and the book quality is 20. So this is a simple example of the linked list in Java. Here we have some different method of the linked list. So I just use a class and then method. Okay. So now here we have, first of all, we have the Boolean list, and how to declare the Boolean list is linked list and then string list object, which is equal to new linked list and then string. Okay, so this is a simple method of the list object as an interface of the linked list string. So what are the Boolean add object item? So it will add the item at the end of the list, like here list and object dot add and end of the list, which is hello. Now it would add the string hello at the end of the linked list. Now we have void add method, which is for indexed and object items. So it will add an item at the given index of the list, like list and object dot add and then to and a string which is by. So this will add the string by at the third positions, means we have the two indexed here is third position as the index start with 0 because we have 0 index 2 and by. Our third method is void, our third method here is boolean add all, and this is collection C. So it will add the element of the specified collection C to the list. It throws null pointer exception if the specified collection is null. So like here I just use an example which is linked list and a string, and then we have list object which is equal to new linked new linked list and then a string and closes a string here. Like this is our means list object means, and here I just define array list and then a string and array list here which is equal to new array it's array list and then a string. Okay, now here I just write array list dot add and we have the string here and then string number 2 and list object dot add all and array list. So this piece of code would add all the element of the array list into the linked list, mean this one. Okay, so these are the some methods of a linked list in Java. So we have the more methods like boolean add all, void add first, void add last, void clear, object clone, and boolean contains, and object get first, object get last, integer indexed of and integer last indexed of, object poll first and object poll last, object remove as a indexed means object remove as a integer index and object remove as the object, and object remove first, object remove last, and object set and integer size. We have some different methods in linked list. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we will talk about the list interface in Java. List is an ordered collection of objects in which duplicate values can be stored. Means you can store the duplicate value in list interface. Since list preserves the insertion order, it allows the potential access and insertion of the element list interface is implemented by the array list and the linked list, and vector and stack classes. So list interface is the sub interface of collection. So it's contain method to insert and delete the elements in the indexed base, and it is a factory of list iterators interface. So now we just come to the example of this list interface in Java. So I just import a library which is java.util, and this is a library. And now we have the class name which is list interface, and I just define the main method, and here we have the main and strings and arguments. Okay, now array, and I just use the array list here because the linked list is the sub interface of the collections. I mean, you can contain the method to insert and delete the elements in the index base, so that's why I'm just using array list here. And a string which is al is equal to new array list. So al mean array list here, and then a string, and here I just write al dot add, and add the name here which is Fayaz. Now al dot add which is Khan, and sorry, now here I just write al dot add, and then I just write, sorry, it is add not add all, this is add, and I just write the Udemy here. And now I just put the value add, and here I just write 2, and I just write the string here which is online. Okay, now print system.out.print, and the print is the print line here. And now I just write, sorry, here element at second position, and now I just write al dot get, and the index here is 2. Now I just use for loop and string, and the string here is s and al. Now system.out.println, and the print line here is s. So I just take a string as an s, and then I just take the parameters of al means the array list what I just add. So I just call these methods, and system.out.println here, so it will print the value of s. So value of s are Fayaz, Khan, Udemy, and online. So here it is proceed, and I just check the output, and we have the array list, and which is the small list here, I think. Yes, now I just proceed this code and check the output again. So this is for the concatenation here, so I just do not add the plus sign here and execute it again. So you can see the element at second position. So first one is the line means line here, then we have means second position elements is online means this is the value of 2, and it will print online. And then we have Fayaz, Khan, Udemy, online, online, and Udemy. So it will just print the second elements like 0, 1, and 2 on online. So this is the example of the list interface in Java. Thanks for watching this lecture. See you in next lecture. Welcome to this lecture, and in this lecture we are going to be discussed about the tree set class in Java. Java tree set class implements the first interface that uses a tree for storage. It inherits the abstract set class and implements the navigable set interface. The objects of the tree set class are stored in ascending order. Here you can see a diagram like first we have iteratable and collection, set, sort array, navigable, set, and tree. So tree always implements from navigable set. Then we will sort the navigable set means it will extend, and then set is also extend from the sort set, and then collections, and then iteratable. So here's some important points about Java tree set classes. So Java tree set classes contains the unique implements only like hash set. It is access and retrieval times and quite fast, and it's maintain ascending order I just told you. So the you can see here the hierarchy of this tree set class. So Java tree set class implements the navigable set interface. The navigable set interface extend the sort, set, and then set, collections, and iteratable interface in hierarchical order. Now we just see the example of this tree set. Here we have the class name which is tree set, and I just import a library which is java.util, and then I just create the adding elements. So tree, set, and string, and then al is equal to new tree set and string, and brackets and closes code. Now al dot add, and add here is Fayaz. Then I just copy this one, and then I just change the name which is Khan, Joy, and Sarah. Now I just traversing these elements. So I iterator and string, and this is itr which is equal to al dot iterator. Okay, so here I just choose while loop, and while itr dot has next, and then system dot out dot println. So the println here is itr dot next. Okay, so this is iterator. So now we just check the output. So this is a semicolon here, and now I just define the main method here. So public static void main, and then string arguments. Okay, and here I just paste this one. So now I just check the output. And you can see we have the four add elements here. And first we just add the element here, means add, al add. So I just create a object which is al and then call the objects and give it the values here, and then iterator strings and create the object to itr here, and then I just write itr.has next, and then I will just print this while loop. So this is the output for our set tree method in set tree class in Java. So thanks for watching this lecture. See you in next lecture. Welcome to this lecture. In this lecture, we are going to be talking about Java sorting algorithm. A sorting algorithm is an algorithm that's put element of a list in certain order. The most used orders are numerical order and lexicogeographical order. Efficient sorting is important for optimizing the use of other algorithms, such as search and merge algorithm, which requires input data to be used list. It is also often used for canonicalizing data and for proceeding the human readable output. So first of all, in Java sorting algorithm, we just see the implementations of the bubble sort in Java. So bubble sort here, and yes, the bubble sort also refers to a shrinking sort. It is a simple sorting algorithm that works by rapidly stepping through the list to be stored. Each pair of adjacent items and swapping items if they are in the wrong order. The pass through the list is represented until no wraps are needed, which indicates that the list is sorted. The algorithms get its name from the way similar elements, which is bubble, to the top of the list because it uses compressions to cooperate on elements. It is a compression sort. All through the algorithm is simple. Most of the other sorting algorithms are more efficient for large list. So here you can see the diagram of the bubble sort. We have the 5 indexed here which are unsorted, and this is the diagram here. So the first step in the diagram, you can see here 5 sorted with 1, sorry, swap with 1. So 1 take the place of 5 and then 5. Means we just go through like 1 and then we have the 5, then 12 and 16. Like you can see here 1, 5, minus 5, 12 and 16. So we just swap our 12 value with 5. Sorry, we have the 5 which is the smaller value than 12. So it is a this swap is okay. So we cannot move the 12 in the place of 5. Then we have 1, 5, 12 minus 5. So we just need to swap this value because 12 is a bigger and 5 is a small value. So 5 take place of 12. So now we just see 12 is smaller than 16. So it is okay. Now you can see 1, 5 and 5 minus 5. This is our first step, means we just sort our this data first. Now we have this index, means this bubble sort is in unsorted form. So you can see here we have the minus 5 which is the bigger value here, which is 5 and 1. So 1, 5, this is okay. 5 and minus 5, so minus 5 is smaller than 5, so we just swap this value, and then 5 and 12 is okay here. Now we just go to the another sort. 5 minus 5, so minus 5 is smaller than 1, so you can see here. Then again 1 and 5 12, so these are in sorted form. So now you can see here minus 5 and 1 15 12 and 16, we have the okay value here. So our sort is means our algorithm is sorted here. Now we just see the coding example of the bubble sort. Like here I just create a package which is sorting, and in this package I just create a class which is bubble sort. Okay, and here our this class is created here. Now I just create the logic to the sorted element. Public static void bubble underscore sort means I just use a keyword which is str. This is not a keyword, but I just use str. Now I just define the length, which is n is equal to array, and array dot length, and then after this I just define an integer which is k. Now I just use the for loop for integer I which is equal to 0, and then so I just use the integer m which is equal to n, and then m which is greater than or equal to 0, and then decrement operator, because we are just sorting these values, so it will compare the value with the last value. So now k which is equal to I plus 1, and if array and I which is greater than array and k, so swap the numbers which is I, k and array. Okay, so it will slap the number which is I, k and array here. Now I just print this number, so print numbers and array. Okay, so numbers will be print here. Now I just write private static void and swap numbers. Here integer I, integer j and integer array. Okay, and now I just write integer temp, and then temp which is equal to array I, and array which is I here, which is equal to array. So I just simply swapping the value here. Okay, and array which is j, and the j is equal to temperature, sorry, it is temporary files. Okay, now private static void print numbers, and the print numbers here, the integer which is, sorry, it's an integer where input, and then system dot out dot print, and the print here is input, and input is the I here. And now I just concatenate, sorry, you define the string which is comma, and here I just use the for loop for integer I which is equal to 0, and then I which is less than input dot length, and here I just write I plus plus. Okay, and I just close this code here. Now system dot out dot print line, and the print line here is just a slash n for a line break, and then I just write public static void main, and then string arguments, and integer which is input, and the input here is the values of the bubble sort which is 4 5 9 3 7 6 and 0 and 1. Okay, and then I just write bubble underscore str and input, and here I just use the for loop for I. So I, sorry, here integer I which is equal to 0, and I is less than n minus 1, and then I plus plus. Okay, so now I just use this one here, and this is a small I, so I plus plus. Okay, so now here we just complete the bubble sort algorithm here, and now we just check the output for this code. So after this bubble sort, you can see here first we have the value of 4 5, and okay, it's 4 5 3 7 6 0 1 9, and it will sort 4 3 5 6 0 1 7 and 9. So after this sorting, first time sort, second time, third time, and at the last we have the sorted value which is 0 1 3 4 5 6 7 and 9. So this is a simple example of this bubble sort in Java. So bubble sort has the worst case and range complexity both, like it use the formula which is 0 and n2. Okay, where n is a number of items being sorted, means the n is the numbers of items where means it are sorted. So there exist many sorting algorithm with subsequently better worth case or range complexity of the 0 n log n. Even other O means O and 2 sorting algorithms such as insertion sort tends to have the better performance than the bubble sort, and therefore bubble sort is not a practical sorting algorithm when n is large. Performance of bubble sort over an already sorted list because means is a best case in O and N formula, like O and N formula. Okay, so this is the example of the bubble sort. Now we just go to the selection sort, and here I just create, so I just remove this one and save, and go to the class which is selection sort. Okay, so the selection sort is a combination. Wait, I just take the picture of this selection sort. Yes, this is the diagram. Okay, so the selection sort is a combination of the searching and sorting during each pass. The sorted element with the smallest or largest value is moved to its proper positions in the array. The number of times the sort passes through the array is one less than the number of the items in the array. In the selection sort, the inner loop finds the next smallest or largest value, and the outer loop places that value into the proper location. First, you can see here we have 5, 1, 2, -5, 16, 12, 2, and 12 and 14. So the selection sort, I just told you that in the definitions of the selection sort, that during each pass the sorted element with the smallest or largest value is moved to the proper positions. I mean, you just simply uh, merge these smallest and largest value together. Like here you can see the 5 and -5. So first we just sort this 5 at the minus side, 5 at the first index. You can see here 5 and -5. Then we have the 1 value here. So 1, -5 and 1. So where no, like there is no smaller value than 1. So we just add the 1 in this index. Then this is okay. Now -5, 1. So 12 and 2. So we just swap these values like 12 and 2. So 12 take the place of 2 and 2 plays the take of 12. Now we just come to the 5. So 5 is okay here, and then 16 and 12. We just swap these two values. So 12 and 16, then 16 and 12. So it's swap 12 and 16 and add the last 16 and 14, and the value is swap here. Now we just go to the example of this selection sort. So I just misprint some spelling in selection sort, so this is okay, no problem. So public static integer, and then do selection. So it's selection and sort, and then integer, which is array. Okay, so for loop, so for integer I which is equal to 0 and I is less than array dot length. So array dot length is -1, and here I just write I plus plus. So length will be -1. Now here I just define the integer which is index, and index is equal to I. For, and the for here is for loop, here is integer j which is equal to I plus 1 now, and then j which is less than array dot length, and j plus plus. Now if array j here and then less than array and indexed, and this is the array index here. Okay, so after this I just write index, which is equal to j. Okay, and now integer, so integer which is smaller number is equal to array, and array here is indexed. So array and then index, which is equal to array and I, and then array here is I, which is equal to a smaller number. Okay, and at the last return array. Okay, so here I think I just did a mistake here. So I and this is j. Okay, so j and j here. Now after that, main method, public static void main, and then strings and arguments. Now integer array number 1, which is equal to 20, 30, 45, 35, 4, 5, 6. Okay, and then integer and array number 2, which is equal to do selection sort. Okay, and then it will print this array. Okay, so print array number 1, and after that for loop. So for integer I, array 2, and system.out.println, and the print line here is I, and system.out.println, and the print line here is comma. Okay, now we just check the output. So here it is showing some error, and I just check public static void main. So I just remove this bracket and one bracket from here, and now I just check the output. So you can see here 4, 5, 6, 20, 30, 35, and 45. So these are our sorted array, which is the selection sort. You can see here 4, then 5, 6, 20, 30, 40, 35, and 45. So this is the selection sort in the Java. And now we just go to the implementation sort. So here I just click the new and class, which is insertion sort. So it's insertion sort. Okay, so insertion sort is a simple sorting algorithm in Java. It's built the final sorted array one item at a one time. It is much less efficient on large lists than other sorting algorithms. The advantages of the insertion sort is it is very simple, efficient for small data sets, and it is stable, like it does not change the retrieve order of the elements with equal keys, and in place like only requires constant inputs of additional memory spaces. Like insertion sort iterates through the list by consuming one input items at each repetition and grow a sorted output list. On a repetition, insertion sort removes one element from the input data, finds the locations it belongs within the sorted list, and inserts it there. It repeats until no input elements remains. We see the diagrams of insertion sort, and here you can see at first step it's swipe the value with 5 and 2, then 4 with 5, then 6 with 5, and then 1 with 2, and then 3 with 4. So at the last we have the sorted form of the insertion sort. Now we just see the coding example of the insertion sort. So we just simply create a class which is the name of insertion sort, and then public static void directly to the main method, and string arguments, and here I just define the integer. So our first integer is array number 1, and which is equal to the indexed value of the array, which is 5, 60, 10, 23, and 12. Okay, and at array number 2, at array number 2 we have do insertion sort and array number 1. Okay, now for int I and array which is 2, and then system.out.println, and the print line here is I, and then system.out.println, and the print line here is comma, and afterwards we just go to the public static integer, and then do insertion sort and integer here and input. Okay, so do insertion sort, take the input here, and now integer temp, use for loop for integer, and integer I which is equal to 1, I is less than input dot length, and I plus plus, sorry it's I plus plus. Now I just use for loop for j, so j is equal to I and j is greater than 0 and j minus minus. Okay, and here I just use if input j which is less than input j minus 1, and then temp file, so temp is the input which is I just call the j here, and then input j which is equal to input j minus 1, and at the last I just write input j minus 1 which is equal to temp. So I just swap this value with the temp which is equal to input j, so I just take the input j as a temp then input j as an input j minus 1, and then input j minus 1 is equal to 10. So I just swipe these values and then return input. Okay, now we just check the output. So you can see here, like we have this output, and this is not the output because I just forget to write the main. And now I just execute this program, and here you can see first sorted element, which is 5, then 10 and 10, then 12, 23, 60. So we have this output for our insertion sort. And now we just go to the quick sort. So this is a quick sort here, and you can see the quick sort or a partition exchange sort is a fast sorting algorithm in Java or any language, which is using dividing and conquer algorithm. Means quick sort means quick sort first divides a large list into the two small sub lists, the low element and the high element. Quick sort can then recursively sort the sub list. So some steps to implement the quick sort, which is choose an element first and then call it pivot. So first of all, you can see here we have the pivot value, which is 5 from the list. So generally pivot can be the middle indexed element, means this will be the middle element, like we have the 9 element, so this is our middle element. Okay, so now recorder means recorder the list so that all elements with values less than the pivot sum before the pivot, while all elements with values greater than the pivot comes after it. Like equal values or equal value can go either way. After the partitioning, the pivot is in the means pivot is in its final position. This is called the partition operations. So recursively apply the above step to the sublist of the elements with smaller values and separately the sublist of the elements with the greater value. Now we just see the divide and conquer rule in the implementations quick sort. We have the pivot 5, and we just swipe this value with the 4. So 4 comes here, and then we just take the two values, 4 swipe with 7 and 8 swipe with 2. So after that we have 3, 4 on the place of 7 and then 2, and then we just divide 7 with 5 and 5 with 8 with 5. So afterwards we have 7 with 1 and 8 with 5. So 5 and 7. So 9. After that we have the pivot value, so we just simply swap this pivot value with 5. So we have 3, 4, 2, 1, 5 and the pivot value, which is 5 here. Now we just go to the example of this quick sort, and it is quick sort. And now here I just write the class which is the quick sort and private integer which is array. And then private integer which is length. Now public void and sort, and then integer here, and then I just write input array. sorry, it's input array. Now if input array, which is equal to null, sorry, it's null, and it is the OR operator to the input array dot length, okay, which is equal to 0, and it will return us the value, and afterwards we just go to the this array, which is equal to input array, okay, and length, which is equal to input array dot length. So we just take the length is equal to input array length, and then quick sort, and the quick sort here is 0 and length minus 1, okay. Now here private void and quick sort, okay, and here I just write integer which is lower indexed, integer which is higher indexed, and then integer I, which is equal to lower indexed, okay, and integer j, which is equal to higher index, okay. Now we just calculate the pivot number, means I am taking the pivot as a middle index number here. So int pivot, so it's a private, so pivot, which is equal to array, and array here is lower index plus higher indexed, okay, minus lower indexed, okay, which is divided by 2. Now I just divide into the two arrays. So while I is less than or equal to j, and here I just take the each iterations, we will identify a numbers from left side which is greater than the pivot value, and also we will identify a number from right side which is less than the pivot value. Once the search is done, then we exchange both the numbers. So here while array, and array here is I, so which is less than pivot, and I plus plus here. Now while array I, which is greater than pivot, and j minus minus here means j is a decrement here. So if I is less than or equal to j, so exchange numbers I and j, and here I just simply move the index to the next position, so I plus plus for the both the sides, so that's why j minus minus. So here I just write if lower, lower indexed, which is less than j. So I will just simply call the quicksort method recursively. And here I just write quick and quicksort, which is lower indexed, and the lower index is j here. Now if, and if is I is less than higher indexed, and the higher index is quick sort, and I and higher indexed. Okay, so I will just call the quicksort method recursively here, and afterwards we just go to the, so it is higher indexed, and now we just go to the private void exchange numbers. Okay, and the integer I here and integer j here. Now we just swap the values. So int temp, which is equal to array I, it's array I, then array I, which is equal to array j, and then array j, which is equal to array I. Okay, temp. Now public, it's array j is equal to temp. So public static void main, and then string arguments, and here my quick sort, and the object which is shorter, which is equal to new, and we have the class of quicksort only, quicksort which is equal to new quicksort. Okay, integer which is the index of input, which is equal to 20, 63, 2, 1, 9, 4, 5, 6, and sorter dot sort, and the input here. And now system dot out dot println, and the println here is I, and then system dot out, it's system dot out dot println, and the println here is nothing. So our code is complete here. So here we just remove some errors, so it is equal to, and create the local variables for the integer index array, and here I just misprint the semicolon, and now here create the local variable for I. So I just remove this character for I here, and now I just run this code after removing all the errors, and you can see here the sorting form of this algorithm is 1 2 4 5 6 9 20, and 63. So these are the some algorithms in Java sorting. Thanks for watching this lecture. See you in next lecture.